Alright, so we can differentiate by rule instead of using first principles. And like I said, you guys are going to hate me for it. If you have x to the power of n, then when you differentiate it, you should have f dash equals to n times x to the power of n minus 1. What that means is you take the power down. So see that power bit that goes to the front. You just subtract the power by 1 and you're done. You don't have to go through all of that extra process. Seems easier, of course, but you have to go through the hard work first before you do the easy stuff. Now, there's a couple of special conditions. They're not really that special, you'll see what they are. For f of x equals to c, where c is a constant, that means if you have a number, for example, a 5 or a 2 or negative 3, whatever it is, then when you differentiate it, you should get a 0. Now, this should make sense because if you have that, for example, f of x is 3, what's our gradient? What's our gradient for that line? 0. That means the gradient should be 0. Right? So that's the reason why. Then if you have all the different terms adding together, you just differentiate each one separately. Now, just a quick thing with notations. I mentioned before that you have f dash of x or dy dx as your notations. You use that if you started off with f of x. You use the other one if you started off with y equals to blah blah blah. Okay? So when you differentiate it and you started off with f of x, you would use f dash of x. If you started off with y, then you would use dy dx. And one last thing is dy dx means you're differentiating in terms of x. So you read the bottom part on which one you differentiate with. Some of you might have noticed when I put this in the calculator, the other way to write this is dx of whatever y is. So you can have x squared plus 2, for example, in there. Okay? Let's just quickly get onto the examples and you'll see how easy this is. A. Calculate d dx of all of that stuff. Now, remember how I said you just take the power down and you multiply it? So d dx of 5x cubed minus 8x squared. We would write the 5. You take the power down. What's our power? 3. So take the 3 down. You subtract the power on the top by 1. Then minus 8. Again, you take the power down. 2x, 2 minus 1. Then you just work those out. 5 times 3 is 15. And then 8 times 2 is... It's nice and quick, isn't it? You guys hate me, don't you? I'm sorry. I have to show you the long way first. Alright, so then we're differentiating that with respect to x. Now, someone tell me what it is without me writing everything out. We're timesing it by 5, so that 1 over 15 is going to reduce to a 3, because 5 times 1 over 15 should be equal to 1/3. If you're not sure, I can show you later. Then minus, what does this one become? 7. Now it's just a 7, okay? Then with the plus 9, that's a constant, so it'll be a 0. So that's the answer. Fairly straightforward, nothing too difficult. C. Now, this is written in that f of x notation, but we have a p and a t. we still do the same thing. We write p dash of t. Now this means we're differentiating in terms of t. Now there is a technique that we can differentiate that with. I'm not going to show you yet because you need some year 12 stuff. So unfortunately we have to expand that first. So 4t squared plus 4t plus 1, then we can differentiate it. So we get 4 times 3, which is 8. That's a 4. That's a 0. Okay? So make sure you expand it first. D. If y equals to all of that, calculate dy dx. So same thing. Make sure you factorize it first. Now if you're not sure on how to do that, separate the fraction. Like so. Once you've done that, x over x is 1. 4x to the power 5 divided by x is? Yep. So then when you figure out the differentiation, see why you need the other notation now? You have a y, so you need dy dx. Differentiating 1 gives you 0. Differentiating this part gives you 16 x to the power of 3.